Welcome to the Simulate webinar series. Today's webinar will be on using simulation for improving staffing forecasting in call center environments. My name is Sander Vermeulen and I'm Head of Services for North America for Simulate Corporation. I've been building simulations since 1998 and I've joined Simulate Corporation back in 2010. Over my time with Simulate, I have worked on quite a variety of call center models. And those include things like inbound and outbound contact centers. I've used simulation for determining staffing requirements, but also to help with staff retention. Other areas include things like introducing cross-skilling agent groups and reducing shrinkage. Today's webinar will focus mainly on staffing requirements for an inbound contact center with the help of cross-skilling agent groups. Today's topics will follow sort of this guide where we first talk about traditional staffing strategies in call centers. And then we go into what the limitations are of these strategies. Then I'm going to talk about what simulation is, what the key properties of simulation are, and why you should be using simulation in a call center environment. Then we're going to talk about some example application areas where you might want to use simulation within your contact center. And then finally, I'm going to show off a demonstration simulation model, which will consist of both a simulation model as well as a Microsoft Excel file that links directly to the simulate model, which will hold all the inputs that are used within the simulation model itself. So let's start off with traditional staffing strategies, and this is typically how most of your workforce management tools will actually work. These are based on an Erlang formula. Erlang is a Danish mathematician back in the early 1900s, and he used to work for a telecom company. The Erlang formula basically calculates the probability that an arriving call needs to queue. So what has been developed over time is an adaptation of that formula that will help you to determine the staffing levels in call centers given a certain call volume and a certain service level requirement. So, as I've mentioned before on the previous slide, a lot of workforce management tools use this approach, this Erlang formula, to determine the staffing levels that will be required for a certain call volume. However, there are some limitations to this strategy, and then primarily to using the Erlang formula, or more precisely the Erlang C formula, which is a derivative of the Erlang formula itself. Firstly, Erlang assumes no abandonment. So it assumes that everyone is willing to queue up until that call can be handled, which in reality obviously is not the case. It also assumes that all calls are handled in the interval in which they arrive. So if we were to use 30-minute intervals, even if that call arrives 29 minutes and 50 seconds into that interval, it still assumes that that call will be handled within that particular interval. It assumes no callbacks. So no callers are expected to hang up, to disconnect, and to try again later when the queues are, hopefully for them, a little bit lower. It assumes a single transaction type. Obviously, in large call centers, normally you'll be dealing with a large volume of a whole wide range of different transaction types. And then finally, it assumes that all of your agent groups will be able to handle all of your different call types, which again is in reality definitely not the case. Certain agent groups will be specialized to handle calls of a different type. So the conclusion here is that Erlang C is no longer a valid technique, a valid tool to use for setting staffing requirements in today's complex and dynamic call center environment. So moving on to simulation. So let's start off by talking a little bit about what simulation is. A simple definition of simulation is that it is a representation of a system as it progresses through time. So here we basically are talking about a computer representation of your system or a simulation model that when you press the run button will repeat or it will run a specific scenario. This is typically a day in the lifetime of a call center where you run a full day's worth of call volumes, and that includes all of the detail that you might have in your call center. So it will give you an accurate representation of what's going on within the system. So when is the right time to use simulation? Well, typically, whenever you can map a system as a series of steps and there is time involved, it will take a certain amount of time for work to progress through the system and to progress through these steps. That is a good indicator on when to use simulation. Obviously, calls will come in a call center through the IVR, hit the ACD, calls will join the back of the queue and they will be handled whenever agents are available. So call centers definitely meet this first requirement. Secondly, systems with a high level of complexity. Well, today's call centers are becoming more and more complex, where we're dealing with different call types, different skill levels on agent groups, different handling times, different abandonment rates, and so on. So definitely call centers are complex environments, and therefore simulation is a very good tool to use within this complex environment. The third requirement here is systems that experience high levels of variability. And I'm pretty sure when you're listening to this webinar that you know about the effects of variability in terms of number of calls offered over time, the number of agents that are available, abandonment, handling times, average speed to answer, all of that stuff is highly variable within a call center environment. So simulation is ideal for helping out with these kind of questions. And then finally, the fourth requirement here is systems that are constrained by resource availability. Now, in order for a call to be handled, obviously we're going to need a call center agent that has the right skill set to match that particular call type. So here, resource availability is definitely one of the things very clearly present within the call center environment, and simulation can be very helpful with modeling and simulating these types of environments. So here is a list of some of the kind of questions you might be willing to answer or might use simulation to answer within the specific call center environment. So, for example, when you're thinking about changing IVR or ACD rules, then before you make those changes live on the real system, you might want to do a simulation to understand the impact before you make those changes, and therefore risking upsetting either your customers or your agents as well. Different call volumes per interval per call type. So if you want to see what's going to happen when you launch a certain marketing campaign, for example, are you still going to be able to hit your service levels? You can run a simulation with increased call volume for specific call types, for specific intervals in the day. And given a certain staffing level and a certain service level requirement, you can exactly see what the performance of that scenario is going to be for your contact center. If you want to see how different abandonment rates per call type have an impact on the overall service level of your call center, you can see that and you can change that. For example, if you want to see what happens with different handling types per call type, for example, when your handling times in the morning are higher than the handling times in the afternoon, or vice versa, you can test all of that complexity easily within a simulation model. If you want to see the impact of changing staffing levels over intervals, you can do that and therefore smoothen or optimize your staffing levels in your contact center environment. You can start looking into cross-training agent groups and increasing skill or proficiency levels for handling certain call types and understand the impact on the overall call center performance before you make those changes live. And then finally, and this is not an extensive list, this is just a series of examples. There is a lot more to be added here, but finally, service levels per call type. So you might want to come up with a tiered structure where certain customers are expected to have higher service level requirements than other customers. You can understand if you want to change to that type of customer service, you can change that within your simulation model before making those changes live and understanding the impact on the overall customer, on the overall call center performance before you make those changes live. So, different applications, and hopefully this becomes clear from the previous list of examples. So, for example, in a very operational level, we can use a simulation model to determine the optimal staffing levels for a specific day. We can understand the impact of cross-skilling agent groups and therefore having an overflow capability on the overall call center performance. We can change ACD rules before we implement them. We can introduce service levels per customer segment. We can change outbound call strategies. What if you were to move certain call volumes to like dinner time, for example? What's going to happen with your sales numbers, for example? Simulation models can be used for staff training and leadership development. So you can demonstrate to your team leaders, for example, the implications of their behavior on overall call center performance. You can introduce new channels, chat or outbound or a whole range of new applications, social media, for example. What happens when you introduce those kind of new channels into an existing call center? And the list just simply goes on and on and on. So what I'm going to show you now is I'm going to show you a demonstration simulation model, which was based off an actual project. And in that project, this call center actually handled about 400,000 daily calls, and they have about 20,000 call center agents on the payroll in total. So quite a high volume contact center. The results from this simulation model are about $20 million in annual savings, and that is realized through a 5% staff reduction overall, whilst maintaining service levels. That is very important to add. Now, what you're going to see in this simulation model is for illustration purposes. It's a demonstration model based on the back of an actual simulation project. However, please don't see that as a limitation for what can be done using simulation, because this is a very a bespoke, a custom simulation model specifically built for demonstrating this kind of staffing requirement. If you have a different way of managing your call center, I am absolutely convinced that we can model that and we can have those changes built into any simulation model that we might develop. So moving on, and I'm first going to start here with the Excel inputs, and hopefully that will give you a little bit of an understanding on how this simulation model works. So I'm going to talk you through a couple of sheets here at the very bottom of this workbook. And I'm going to start off by showing you a sheet for the call volume. So firstly, I'm going to point you to the top in row number 1, where we can see the numbers 1 through 20 on columns B for Bravo all the way through U for uniform. So as you can clearly see, this simulation model runs for 10 hours per day between 8 a.m. and 6 p.m. Each interval has a duration of 30 minutes. This particular sheet is used to determine the call volume for this day of simulated time, where you can see that we are dealing with a total of 10 different call types. And on the intersecting cells between the columns and the rows, we can see the call volume for that interval for that particular call type. So between 9 a.m. and 9:30, we expect to receive 140 calls of call type 5. And I am deliberately using the word expect to see. That is an average value, in the sense there will be variability in the number of calls offered, but the average, if we were to repeat this experiment multiple times, will be about 140 calls arriving in that call volume. Calls will arrive randomly distributed through that 30-minute interval as well. So it's not like we divide 30 minutes by 140 calls in order to determine the time between calls. Calls will come in distributed randomly, but on average we will see 140 calls of call type 5 arriving in this interval. The second sheet is the sheet for staffing levels, and it follows a very similar type of pattern in the sense that we can see the intervals going across the columns, but this time we can see the agent groups. We've got 10 agent groups in this staffing model, going down the individual rows from row 4 all the way down to row 13. And again, on the intersecting cells, we can see the staffing levels for agent group number 6 between the hours of 10 a.m. and 10:30, which is 25, the cell that I just highlighted. So this is how we can configure the simulation model for staffing levels. As mentioned before, this is a demonstration model, so we've got 10 different call types, we've got 10 different agent groups. All of those numbers obviously can be changed. So let's talk a little bit about how agent groups are assigned to different call types. So for that, we've developed this matrix. Going across the columns, here at the top of the screen, we can see all of our different call types. Going down the rows, we can see the agent groups. Now, in the intersecting cells, you have 4 options. There can either be a blank cell or a numerical value, 1, 2, or 3. That numerical value indicates the proficiency level for an agent group to handle a call of a certain call type. So, for example, agent group number 4 has a proficiency level of 1, which is the highest level, so the lower the number, the higher the proficiency level, of handling any incoming calls of type 4. So this agent group is highly proficient in answering calls of type 4. It has a medium proficiency level for call type 5 and a low proficiency level for call types 6 and 8. That agent group has no proficiency whatsoever for handling any of these calls 1, 2, or 3, 7, 9, and 10. So these numbers, this is dynamic, we can change that, and therefore basically cross-training this agent group if we want to. So this matrix determines what agent groups can handle what calls and how proficient they are in handling those calls. So let's have a look in the next sheet, which is all about the handling time, and let's have a look at call type 4. So for call type 4, we have 3 values for the average handling time: 212 seconds, 230 seconds, and 245 seconds. And those values depend on the proficiency level of the agent group that is handling this call. So obviously, the better the training for that call center agent group, the lower the average handling time. So we are striving to get all of our calls handled by agent groups with a proficiency level of 1. That will optimize the overall average handling time within our call center, and therefore driving down average speed to answer and increasing the service levels. The last two sheets are very simple. The first one is we have different abandonment rates for different call types, and abandonment rates here are actually defined as the willingness for customers to wait to be handled. So that's your average waiting time. So customers for call type number 4 have an average willingness to queue of about 405 seconds. And then the last sheet here drives our service levels. So here you can see that we have a flat 80% of calls have to be answered within 30 seconds. But again, certain calls can be more important than other calls, and if we want to do that, we can easily change that here in our inputs. So enough about the inputs, and let's actually look at what that looks like within the simulation model. So this is basically what the simulation model looks like, or to be more precise, what the dashboard of the simulation model looks like. The actual simulation model is hidden here under this button, and if I double click, I can bring that up and you can basically see the structure of this call center model. So we have an IVR that generates call outputs. Calls will then move to the ACD where they go into one of the 10 different queues. That depends on the call type. Call type 1 goes to the first queue, call type 7 will go to queue number 7. And here they will be waiting for an agent group with the right skill set to handle that call. So on the main dashboard, on the main screen, we can see a dashboard, and this is just a graphical representation of what is going on within the contact center environment. I'm going to press run while I'm explaining what you can see upon the screen. So as soon as I press run here in the upper right hand corner, you can see that the hands on the clock are starting to move. So the first part of the screen here gives you a snapshot of what is going on within the contact center environment. This is set up so that it will update every 30 minutes on a new interval, and we can see for the whole call center as well as the individual queues the total number of calls offered, the total number of calls handled, and the total number of calls abandoned. In addition to that, in those little blue boxes over here, you can see an accurate representation of the queue size within each of those queues and within the whole call center. In the lower half of the screen, we can see two charts, and these are high-level charts for the whole call center. The one on the left, we can see a chart for the service level. So going across here are the interval numbers. So interval number 1, I believe, was between 8 a.m. and 8:30 in the morning. And we can see the service level for that interval is actually probably close to 100%. What you can see is from the sheet that we talked about earlier in the Excel file is we have a service level requirement of 80% of the calls handled within 30 seconds. So each of those green columns here indicates a service level hit. The red columns indicate a service level miss, and you can clearly see that this column is actually below the 80% number over here. As I mentioned before, this is a generic chart for the entire call center, not for a specific queue. This is just for the whole call center. On the right hand side, we have a chart for our agent occupancy. So here we can see across all of the 10 different agent groups that we have, the average, this is a weighted average, occupancy rates for each of those agent groups. So all of our agent groups at the start of the day, the system is still warming up, and you can see that the occupancy goes up in the middle of the morning. Now obviously what we want to do here is we want to look at individual agent groups, because we need to know exactly where things are getting really busy and we might want to adjust some staffing levels. So what we've done here is we've created this button that allows us to look at individual agent group occupancy. So let's have a look and let's pick any of these random agent groups from our simulation model, and let's have a look, for example, at the occupancy levels for agent group number 3. And you can see that it follows a similar pattern as the overall chart. Well, we can do that for any agent group. So we can change to any of the 10 agent groups in our simulation model, and you will see the actual occupancy chart for that agent group. In addition to looking at agent group occupancy, we can also look at queue results in a little bit more detail. So let's do that. Let's pick a random queue. And let's have a look on what we can see over here. So first of all, we can now look at the service level queue for queue number 3 in way more detail. So here we can see that even though the service level for the whole call center was significantly better, we can see that there is a bit of an issue going on in this queue over here, particularly between intervals 12 and 16, where we have almost like a constant miss over here on the right hand side. But in addition to that, we have some additional information. For example, if you would like to see the average speed to answer for queue number 3 specifically, we can have a look and see exactly what the average speed to answer was, per interval obviously. If we want to understand abandonment for this queue, we can see that over here. We can see the average handling time, and even though the handling time was defined as an input, it is actually also an output. Do you remember that we have 3 different handling time values, one for the highest proficiency level, one for the medium proficiency level, and one for the lowest proficiency level? That means that depending on our staffing profile, the handling time, the average handling time, can either be higher or lower, in the sense that if a lot of calls overflow to agent groups with a lower proficiency rate, you will see that the average handling time on that interval will be significantly higher than any of the other ones. So to determine if there was a lot of overflow going on, there is also an accuracy chart. And here accuracy has been defined as the percentage of calls that have been handled by an agent group with the highest skill for answering this call type. So obviously we are striving for a 100% accuracy rate, which means that all of the calls in that interval have been handled by an agent group with the highest proficiency level for that, for handling that call type. So as you can see, throughout the day, there is more or some less, depending on the interval, overflow going on. This chart does not tell you if it was overflown to a medium or a low proficiency level, but again, if that is of interest, that can easily be added to the outputs from the simulation model. So let's have a look at another queue, for example. So pick another one at random. Let's go with 8. And we can see that the numbers here have updated. The handling time apparently for queue number 8 is significantly lower than the one for queue number 3. So these are easier questions to deal with. But here you can see the impact of a presumably a low accuracy number. So looking at the service levels, we can see that we have 1, 2 service level misses, interval number 12 and interval number 15. So let's see if we can fix that, right? So I'm going to close this dialog, and what we're actually going to do is we're going to go back into our Excel file, into our staffing levels. So what we were looking at interval number 15 for agent group number 8. So the assumption here is that the staffing levels for that interval were too low to hit the service levels that were defined as 80% of the calls handled within 30 seconds. So what I'm going to do here is I'm going to increase that, and I'm just going to round that to the next 10 agents, so make that 50. And what I can do now is I can simply go back into my simulation model, and here at the top we have a button that will simply import the data. So this is going to do two things. It's going to move the data across from Microsoft Excel. It's going to load all of that information. But secondly, it is going to reconfigure our simulation model, because what we can do in one of the sheets is, for example, cross-train agents. That means that agent groups are now going to be potentially able to handle different call types. So the whole resource allocation, how agents are assigned to call types, will be changed as well during this phase, during the data import. So now that the data import is complete, I can reset my simulation model and I can press run again. And since we've already looked at what it looks like to run the model at a relatively low speed, I'm going to increase the speed of the simulation. And you can now see the clock starting to jump between the different intervals. So just a few seconds later, our run is complete. And we now want to see the impact that our change in staffing levels have made. Now, what we can instantly see is that, yes, we still have 3 breaches of the service level, but those are now in a different location. So let's have a look at the impact that we've made on queue number 8, still selected, and we changed interval number 15. So you can see that we've actually, the staffing levels are probably a little bit too high now, because we are at 90% service level for that interval. So hopefully that will demonstrate to you how you can accurately test your staffing levels using a tool like Simulate. And you will get an accurate representation of your system and therefore a really good understanding of your staffing requirements, and hopefully you will be able to test some changes to your call centers and making quite substantial financial savings. So that concludes this part of the demonstration. Let me very quickly bring up the applications slide again. So just to remind you that these are some of the applications that you can test using a tool like Simulation. So we've looked at determining the optimal staffing levels, and implicitly we've looked at cross-skilling agent groups. We can dynamically do that by assigning different values in that one sheet within Excel. But there is a whole range of other things you can do within your call center environment, and testing those changes using a tool like Simulate will give you an accurate representation of the performance before you make the actual change. So any deficiencies in your strategy, you can fine-tune before the change will go live. That concludes my presentation. That concludes this webinar for today. If you would like to reach out to us, I've put the contact details on this slide, and you are more than welcome to reach out and ask for any more information. We'd be happy to explain that to you. For now, I would like to thank you very much for joining this webinar, and I wish you a very nice day.